Hello friends, we want to continue with our lessons on trigonometry, and we are moving on to trigonometry 14, and we'll be considering some important items as well. So we want to look at compound angle identities, and over here we'll be looking at trig ratios for angles such as a plus b, a minus b, in terms of the trig ratios of a and b. Now I want to remind ourselves that it is dangerously easy to think that sine a plus b will give you sine a plus sine b. Let's look at this example. Sine 45 degrees plus 45 degrees will give us sine 90 degrees, and that will give us 1. But sine 45 degrees plus sine 45 degrees will give us root 2 on 2 plus root 2 on 2, which will give us 2. And that is not equal to the 1 that we got over here. So clearly, this and that will not be equivalent. And so we want to see how we can express this in terms of sine A and sine B. And that's what we are going to do, to use some diagrams to help us find that in the geometrical sense. Thank you so much. Let's move on. So over here, we'll be using this right angle triangle. It's in various forms. We have this as right angle triangle. This is also one of them. The whole of this is also one of them. Then we also have this as another right angle triangle. And we'll all see that our URQ over here have this URQ here will also be equal to A, and we have it in other forms as well. Great. So from the diagram, we want to compute sine A plus B. So our angle A is here, angle B there. So the whole of this A plus B. So that will give us this right-angled triangle. Okay, so we'll be using that to find our sine A plus B. So sine A plus B, sine is opposite over hypotenuse, and so we'll be doing that. So here the opposite is TR, then hypotenuse is OR. So sine A plus B is TR over OR. Now we can see that TR can be expressed as TS plus SR, and so that's what we have done here. So in place of TR, we have TS plus our TR, and once we do that, we can then move on. So TS plus SR over OR, and then from there, we can also write our TS in terms of PQ. So TS is also equal to PQ. So in place of TS, we put our PQ there. Now PQ over OR plus SR over OR. And that is what we have gotten now. So friends, we will then move on in expressing our PQ over OR in terms of two trig ratios. So over here, we want to find our PQ over OQ times OQ over OR, which will still take us back to our PQ over OR, because this and that will divide and that takes us back. And then this and that will divide and that will take us back to SR over OR. So right away, our PQ over OQ will define sine A. Our PQ over OQ will define sine A. So let's look for our sine A. So over here, and sine is opposite over our hypotenuse. So that will be PQ over our OQ. So that gives us our sine A. Now for our cos B, we are moving on. So we are looking for our cos B. Now come here. Look at our cos B. So our cos B will be adjacent over hypotenuse. So our adjacent is OQ over our OR. So adjacent OQ over hypotenuse OR. So that gives us our sine B. So the whole of this gives us sine A cos B. Now we want to move on. We are now looking for our SR over QR times QR over OR. Now that means that the whole of this will give us our cos A. So for cos A, we move on to this. So let's look at this carefully. Our angle is here. So this side, and then that side. So we look at it. So our cos. So this side will give us our adjacent, opposite, and then the hypotenuse. And cosine is adjacent over hypotenuse. So our adjacent is SR. Our hypotenuse is QR. So our cos A will give us our SR over our QR. So that is for this one. Now over here too, we are now going to look for our sine B. So we move over here, our sine B. So we are looking for our sine B. And want to remember Now our sine B will be opposite over our hypotenuse. So that will be our QR over OR for our sine B. Now you could see that, so our sine A plus B can be expressed in sine A cos B plus cos A sine B. So look through it from this point up to this point, then relate it to the diagram. You see that easily you can generate our sine A plus B in this form. Great. Now, similarly, as we derive sine A plus B giving us this, sine A minus B will give us sine A cos B minus cos A sine B. Cos A plus B will give us cos A cos B minus sine A sine B. Then cos A minus B will give us cos A cos B plus sine A sine B. Tan A plus B will give us tan A plus tan B all over 1 minus tan A tan B. Then tan A minus B will give us tan A minus tan B over 1 plus tan A tan B. So look through it, register all this on your mind. Right. We want to look at some examples on what we have just treated. So we want to compute sine 165 degrees. So sine 165 degrees, we can write it as sine 120 degrees plus 45 degrees. So this can be our A and that can be our B. Now, using the compound angle identities, we have sine 120 degrees cos 45 plus cos 120 degrees sine 45 degrees. Now, we can simplify the sine 120 degrees as sine 60 because in the second quadrant, sine 120 is the same as sine 60 and that will be positive. So sine 60 degrees cos 45 degrees. Now, cos 120 degrees in the second quadrant can be written with its acute angle as negative cos 60 degrees and then our sine 45 degrees. In our previous slides that we treated a long time ago, we calculated sine 60 cos 45, cos 60, sine 45. We treated all this and even tan and all that. So sine 60 degrees will give us root 3 on 2, cos 45 degrees will give us root 2 on 2, cos 60 will give us half, and sine 45 will give us root 2 on 2. So we have 4 over here, have 4 over there, so our LCM will be 4. Now this 4 dividing, that will give us 1. So 1 times root 3 root 2 will give us root 6. Then this 4 dividing, that will get 1. So 1 times root 2 will give us root 2 with our minus. So when we simplify it, our denominator will be 1 on 4. So we get 1 on 4. And then this bracket root 6 minus root 2. So that's how we can simplify sine 165 degrees using the compound angle identities. We want to show that the left-hand side is equal to the right-hand side. We can also move from the right-hand side to the left-hand side. So we are going to use the compound angles to express this. So sine A plus B give us sine A cos B plus cos A sine B all over cos A cos B. Now this plus this a term and that's a term, so all of them will be over the cos A cos B. So you have sine A cos B over cos A cos B. Now cos B will divide and you get sine A over cos A and that will give us tan A. Now cos A sine B over cos A cos B, then cos A will divide and get sine B over cos B and that will give us tan B. So we've been able to express this in terms of that in this way. So we will convert this to that and look at the steps. Look at the steps. That's great. Now we want to express sine theta plus 60 degrees in terms of sine 120 degrees minus theta. So we use the compound angle, so sine theta cos 60 degrees and then cos theta sine 60 degrees. Now, when we come here, we can look at all these expressions that we have over here. Now, the cos 60, that is sine 60, we can write it as sine 120 times our cos, and so that's what we have over here. And then in that quadrant 2, sine 120 is positive. And then our cos 60, we can write it as cos 120, and that will actually be negative. And so basically, times our sine, so we have it this way. Now we can simplify this in terms of sine 120 degrees minus theta. So we get sine 120 cos theta degrees and then cos 120 degrees sine theta. And so that gives us this one. So we've been able to write this as that will give us 120 cos, that is sine 120 degrees minus theta. So look at it carefully. Remember how we deal with that. All right. Okay. That's fantastic. So, my good friends, thank you very much for your attention and have a blessed day. Bye.